Hello everybody, in this video I will discuss a typical exam question on analytical geometry. In the diagram, triangle PQS is drawn with vertices P, -2, 3, Q, 3, 6 and S in a Cartesian plane. Line QS passes through the origin at O. PS is parallel to QR. Angle PSQ is equal to 20,23 degrees. Number 1. Calculate the gradient of line QS. Now, if only we knew the coordinate of S, it would be so much easier because we only have one coordinate here, and that is Q's coordinate, the point 36. But there is some hidden information here in the words where they tell us that line QS passes through the origin at O, and we know that O, the origin's coordinates are 0, 0. So indeed we have two coordinates living on QS, therefore we can calculate the gradient with the gradient formula. And then I advise you always go back to your coordinate that you're going to substitute and write this is Q, x of Q, y of Q, x of O, y of O. And then you substitute the values. The gradient QS is 6 minus 0 over 3 minus 0. In the end, your gradient of QS is 2. And now that you know the gradient, remember, you will use that in the next sum. Question 2. Calculate the size of theta. Now remember, in the previous sum, we worked out that the gradient of QS is 2. Now when you go to theta, can you see that theta is indeed the inclination of line QS? Remember, the definition for inclination is it's the angle between the line and the positive x-axis measured in an anti-clockwise direction. So we can work out the size of theta by using the formula for inclination. M is tan theta. And from the previous sum, we worked out that the gradient of QS was 2. Therefore, it's 2 is tan theta. And then to work out the angle with your calculator, you're going to say shift tan 2 equals. And then the answer, theta size is 63,4 degrees. And remember, you can use that now in the next question. Question 3. Determine the gradient of PS rounded off to the nearest whole number. Now the first thing that's happening here is, can you see that angle TOS is equal to theta? And the reason is vertically opposite angles. And remember, you can use your rules that you've got for Euclidean geometry here in the analytical geometry. Now, since we know the size of TOS, it's theta, and then we can go to angle STO. You will see I made it blue for you there. And you've got O's size, which is theta, and you've got S's size. Therefore, you can work out the size of STO with your theorem, angles of a triangle. And then you can say angle STO is 180 degrees minus 63,4 plus 20,23. That is S and theta. And your reason, angles of a triangle. And then the size for STO is 96,37. That's the blue angle. Now, since you know the size there, you can work out the size of alpha with your theorem angles on a straight line. So alpha size is 180 minus 96.37. There, that one is in green. And then alpha is 83.63 degrees. Now the question was, we need to work out the gradient of PS. And what we know is, if you look at alpha, can you see that alpha is the inclination of line PS? And we have a formula. M of PS is equal to tan alpha. That's the formula for inclination. And we know the size of alpha. We just calculated it was 83.63 degrees. Then we can work out the gradient of PS. Remember, you are working out the gradient, so there's no need for you to use shift tan. You only slot into your calculator tan 83.63 and you find the gradient for PS is 8.957. But the question asked for the gradient rounded off to the nearest whole number. Therefore, you just need to make PS into the nearest whole number. Therefore, PS is equal to 9. Number 4. Determine the equation of line PS. To find the equation of a straight line, we use the formula y is mx plus c. What we need is a gradient, but we know the gradient from the previous sum. We calculated PS's gradient to the nearest whole number was 9. Then we need a coordinate that lives on the straight line. You agree we don't know S's coordinate, but what we do know is we have P's coordinate. It was given as -2, 3. So we're going to use that coordinate. X is -2 and y is 3. And the gradient we calculated in the previous sum was 9. So in y's place goes 3, in x's place goes -2 plus c. And then 9 times -2 is -18. -18 will walk across, it becomes plus 18, and it adds with that 3. Therefore, c's value is 21. And then, just to conclude, the equation of PS is y is 9x plus 21. Question 5. If it is further given that QS is y is equal to 2s, well, there's s, determine the coordinates of s. Now let's see. PS and QS, they intersect at S. And then what is the rule? When two lines intersect, we use simultaneous equations to work out the point of intersection. Now let's see. Given was that line QS's equation is y is equal to 2x, and the other line PS, the equation for PS, we worked it out in the previous sum. That one was y is equal to 9x plus 21. So both the lines are in standard form. Therefore, to do the simultaneous equations, we can equate the two lines, and it becomes 2x is equal to 9x plus 21. Let's get all the x's on one side and the constant on the other side, and we end with 9x minus 2x is 7x. And then to solve x, divide by 7, divide by 7. And x is minus 3. To get the corresponding y coordinate, we're going to say sub x is equal to -3 into, and you can choose either of the two equations. I chose y is equal to 2x. It looks easier. Into x's place goes -3. Therefore, the y coordinate at S is -6. And then you have to write the proper coordinate. Therefore, S's coordinate is -3, -6. Question 6. Calculate the length of QS in simplified third form. Now from the previous sum, we worked out S's coordinate was -3, -6, and Q's coordinate was given as 3, 6. To find the length of QS, we're going to use the distance formula. Now the two coordinates, you write them there for yourself. S's coordinate -3, -6. So you write the above the coordinate x of s, y of s, x of q, y of q. And now it's much easier to substitute. So when we substitute, it's going to be -3 minus bracket 3 squared plus -6 minus bracket 6. And then -3 is -6 squared, and -6 minus -6 is -12 squared. -6 squared is 36 plus -12 squared is 144. And then 144 plus 36 is 180. So we've got root 180. But the question said they want QS in simplified third form. So to simplify root 180, what you do is you write it as 36 times 5. It's usually one of the numbers will be a perfect square. And then you say the square root of 36 is 6, and you're left with root 5. Therefore, the length of QS in simplified third form is 6 root 5. In the next video, I will discuss another exam question on analytical geometry. Please like my video and then click on the video in the left-hand corner to take you straight to that exam question.